the electrical bonding appears to be insufficient. A crucial aspect of electrical safety is ensuring proper bonding and grounding of various metallic components within a building's electrical system. Firstly, the water pipe should be bonded to the grounding bar. A bonding clamp is generally used for this purpose to create a secure and reliable connection. The absence of this connection compromises the grounding path for the water pipe system. Secondly, if a gas pipe is present, it also needs to be bonded to the grounding bar. Similar to the water pipe, this is typically achieved using a bonding clamp. Bonding the gas pipe helps to prevent the buildup of static electricity and provides a path for fault current in case of an electrical fault. Thirdly, all electrical panels should be bonded to the grounding bar. This is typically done with a bonding screw or jumper wire. This ensures that the panel enclosure is at the same electrical potential as the grounding system, reducing the risk of electrical shock. Fourthly, if there is any metallic conduit present, it should be bonded to the grounding bar. This can be accomplished using bonding bushings or other approved methods. Bonding the conduit ensures that it is grounded and can safely carry fault current back to the source. Any metal equipment frame should be bonded to the grounding bar. This includes things like HVAC units, large appliances, and other metallic equipment. Bonding these frames provides a path for fault current and helps to prevent electrical shock hazards. Proper bonding creates a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device, such as a circuit breaker or fuse, to quickly trip and clear the fault. This helps to minimize the risk of electrical shock, fire, and equipment damage. The National Electrical Code, or NEC, provides specific requirements for bonding and grounding electrical systems. It is important to consult the NEC and follow all applicable requirements to ensure that the electrical system is safe and compliant. Grounding and bonding are not the same thing, although they are often used together and are related. Grounding refers to connecting the electrical system to the earth, while bonding refers to connecting various metallic components within the electrical system together. Bonding is necessary to ensure that all metallic parts are at the same electrical potential, which helps to prevent electrical shock hazards. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. These electrodes are connected to the grounding bar in the electrical service panel, which provides a path for fault current to flow back to the source and to the earth. The size of the bonding conductors is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the bonding conductors based on the size of the service entrance conductors. It is important to use the correct size bonding conductors to ensure that they can safely carry fault current. Bonding connections should be made using approved methods, such as bonding clamps, bonding bushings, or exothermic welding. These methods ensure that the connections are secure and reliable. Bonding connections should be accessible for inspection and maintenance. This allows for periodic inspection of the connections to ensure that they are still in good condition and that they are providing a reliable grounding path. In addition to the specific requirements for bonding water pipes, gas pipes, electrical panels, conduit, and equipment frames, the NEC also includes general requirements for bonding all metal parts that are likely to become energized. This includes things like metal enclosures, metal raceways, and metal supports. All of these metal parts should be bonded together to create a continuous grounding path. The grounding bar is a critical component of the grounding and bonding system. It serves as the central connection point for all of the grounding and bonding conductors. The grounding bar should be securely mounted and should be large enough to accommodate all of the grounding and bonding conductors. It is important to properly torque all of the bonding connections to ensure that they are tight and secure. Loose connections can create a high resistance path, which can impede the flow of fault current and increase the risk of electrical shock. Regular inspection and maintenance of the grounding and bonding system is essential to ensure that it is functioning properly. This includes visually inspecting the bonding connections, testing the continuity of the grounding path, and measuring the ground resistance. Any problems that are identified should be corrected promptly. If you are not familiar with electrical bonding and grounding requirements, it is important to consult with a qualified electrician. A qualified electrician can inspect the electrical system and identify any bonding deficiencies. They can also make the necessary repairs and upgrades to ensure that the electrical system is safe and compliant. The purpose of bonding is to create an electrically safe environment by ensuring that all metallic components are at the same electrical potential. This minimizes the risk of electrical shock by preventing voltage differences between conductive surfaces that could be touched simultaneously. Bonding helps to reduce electrical noise and interference in sensitive electronic equipment. By providing a low impedance path for unwanted currents, bonding can minimize the effects of electromagnetic interference, ensuring proper equipment operation. Bonding provides a path for fault current to flow back to the source, allowing overcurrent protection devices to operate and clear the fault. This prevents the buildup of dangerous voltages and reduces the risk of fire and equipment damage. The NEC specifies the methods for bonding different types of equipment and systems. These methods include using bonding jumpers, bonding screws, bonding bushings, and exothermic welding. The NEC specifies the size of bonding conductors based on the size of the overcurrent protection device. The bonding conductor must be able to safely carry the available fault current without overheating or melting. The NEC specifies the requirements for bonding different types of metal enclosures, such as electrical panels, junction boxes, and equipment cabinets. These enclosures must be bonded to the grounding system to ensure that they are at the same electrical potential as other grounded components. The NEC specifies the requirements for bonding metal water pipes and gas pipes. These pipes must be bonded to the grounding system to prevent them from becoming energized due to electrical faults. The NEC specifies the requirements for bonding metal conduit and cable trays. These raceways must be bonded to the grounding system to ensure that they are at the same electrical potential as other grounded components. The NEC specifies the requirements for bonding metal equipment frames and chassis. These frames and chassis must be bonded to the grounding system to ensure that they are at the same electrical potential as other grounded components. Bonding is an essential aspect of electrical safety and should be performed by a qualified electrician. Proper bonding helps to prevent electrical shock, reduce electrical noise, and ensure the safe operation of electrical equipment. Grounding is a separate but related concept that involves connecting the electrical system to the earth. Grounding provides a path for fault current to flow back to the source and helps to stabilize the voltage of the electrical system. Bonding and grounding work together to create a safe and reliable electrical system. Improper bonding can lead to dangerous electrical conditions and should be corrected immediately. Regularly inspect the bonding connections to ensure that they are tight and secure. Loose connections can create a high resistance path that can impede the flow of fault current. Test the continuity of the bonding system to ensure that there are no breaks or high resistance connections. A continuity test will verify that there is a low impedance path between all bonded components. Measure the ground resistance to ensure that the grounding system is effective. A high ground resistance indicates that the grounding system may not be able to effectively dissipate fault current. If you are unsure about any aspect of electrical bonding or grounding, consult with a qualified electrician. An electrician can inspect your electrical system and make any necessary repairs or upgrades. Always disconnect power to electrical equipment before working on it. This will help to prevent electrical shock. Use appropriate personal protective equipment such as rubber gloves and safety glasses when working on electrical equipment. This will help to protect you from electrical shock and other hazards. Follow all applicable electrical codes and standards when performing electrical work. This will help to ensure that the electrical system is safe and compliant. Do not attempt to perform electrical work if you are not qualified. Electrical work can be dangerous and should only be performed by qualified professionals. Bonding is not just about connecting wires together, it's about creating a reliable and effective electrical safety system. The materials used for bonding connections must be compatible with the metals being joined to prevent corrosion. Aluminum and copper, for example, require special connectors to avoid galvanic corrosion. The path of the bonding conductor should be as short and direct as possible to minimize impedance. Long, looping bonding conductors can increase impedance and reduce the effectiveness of the bonding system. The bonding system should be designed to withstand the maximum available fault current. This requires careful consideration of the size and type of bonding conductors and connectors. The bonding system should be regularly inspected and tested to ensure that it is functioning properly. This includes visual inspections, continuity tests, and ground resistance measurements. Bonding is a critical component of a comprehensive electrical safety program. It helps to protect people and property from electrical hazards. A thorough understanding of bonding principles and practices is essential for anyone who works with electrical systems. The principles of bonding are based on fundamental electrical concepts such as Ohm's law and Kirchhoff's laws. These laws govern the flow of current and voltage in electrical circuit. The application of these principles is crucial for designing and implementing effective bonding systems. The purpose of bonding is to minimize voltage differences between conductive surfaces. This is achieved by creating a low impedance path for current to flow between these surfaces. The lower the impedance of the bonding path, the more effective the bonding system will be. Bonding is particularly important in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. In these areas, special bonding requirements may apply. The NEC contains specific requirements for bonding swimming pools, hot tubs, and other bodies of water. These requirements are designed to protect people from electrical shock hazards. Bonding is also important in industrial and commercial settings where there is a high concentration of electrical equipment. In these settings, a well-designed and maintained bonding system is essential for preventing electrical hazards and ensuring the safe operation of equipment. The effectiveness of a bonding system can be evaluated by measuring the voltage difference between different conductive surfaces. A low voltage difference indicates that the bonding system is functioning properly. A high voltage difference indicates that there is a problem with the bonding system that needs to be corrected. Bonding is an ongoing process that requires regular inspection and maintenance. The bonding connections should be inspected periodically to ensure that they are tight and secure. The bonding conductors should be inspected for damage or corrosion. Any problems that are identified should be corrected promptly. Bonding is not a one-size-fits-all solution. The specific bonding requirements will vary depending on the type of electrical system and the environment in which it is installed. It is important to consult with a qualified electrician to determine the appropriate bonding requirements for a particular application. Bonding is a fundamental aspect of electrical safety that should not be overlooked. By following the principles and practices of bonding, you can help to protect people and property from electrical hazards. Furthermore, remember that while this explanation covers many common scenarios, specific local codes and regulations may add further requirements. Always consult with a licensed electrician or a relevant authority for specific applications.